Hi, I'm Rock, a PhD student at the University of Washington. I'm excited to share with you our new work, BLIP, facilitating the exploration of undesirable consequences of digital technologies. This is a joint work with Sebastin Santy, Rene and Katharina Reinecke here at the University of Washington. With the rise of digital technologies in our lives, society has not only experienced their benefits, but also their undesirable consequences. Nowadays, we're increasingly seeing these consequences on news headlines or research papers. These issues may occasionally be dismissed as minor glitches or incidental blips in the grand technological narrative. However, journalists, researchers, and policymakers have suggested that many of these challenges are not merely incidental. Many cases could have been avoided if researchers and technology developers were aware of similar issues and had taken cautious evaluation beforehand. As a result, our system, BLIP, is founded on the premise that by cataloging and analyzing these blips, we can transform them from overlooked incidents into pivotal learning opportunities. This approach empowers researchers to anticipate and mitigate risks proactively, fostering a more responsible technology development. While prior work have proposed many ways to forecast and anticipate undesirable consequences of digital technologies. One prominent example is design cards toolkits such as the tarot cards of tech and the envisioning cards. However, using these methods require prior knowledge on the topic at hand, which may not always be the case for novice users. Another example is the Delphi forecasting method, which is a process of forecasting using the collective opinion from a panel of experts. One issue for this method is that they usually rely on experts to collect and interpret historical data in a team, which is difficult for individual CS researchers and developers to use. Finally, BLIP was inspired by prior work that have created databases and forums to learn about past incidents. In contrast to prior work, BLIP catalogs the information from many diverse CS subfields automatically using large language models. In addition, this paper provides an in-depth evaluation on how CS researchers perceive this catalog of consequences. Before diving into BLIP, let's quickly imagine the undesirable consequences of social media. First, perhaps you have read some papers and you have some prior knowledge, and you can think really hard or consult with experts in the field. Or perhaps you would like to search online to look through articles and decide which ones are relevant and important. Or maybe you want to ask ChatGPT to generate the ideas and you decide for yourself whether you will be able to trust the claim. In any case, please let us know if you have any ideas. We'd love to hear from you. In this paper, we offer a different approach to do this with BLIP. Inspired from the creativity support and sense-making literature, BLIP is a research prototype that extracts, summarizes, and categorizes real-world undesirable consequences from technology magazines and academic papers, and present them through an interactive web interface to support users' exploration. While BLIP collects tech articles from popular technology magazines as content source, then curate content about undesirable consequences. In this content curation step, BLIP first uses a pre-trained large language model to determine whether an article mentions undesirable consequences based on the title and content information. Second, BLIP leverages the large language model to summarize long articles to succinct summaries specifically about undesirable consequences to help users explore more efficiently. Third, BLIP also uses LLMs to categorize each article based on unique general categories or life aspect in our paper, such as economy, security, and privacy, so that users can further explore a more diverse set of consequences. Finally, we display the curated information on an interactive web interface. Here we show how a user can explore the BLIP interface. On the interface, users can read the succinct summary specifically about the undesirable consequences discussed in a long article. For example, this first article from the MIT Tech Review talks about the messy and secretive reality behind OpenAI's bids to save the world. Take another example, This article talks about some security and privacy concerns of using brainwaves to guess passwords. And this article is about how experiments in AI education could reshape how the world learns. On the BLIP interface, users can select relevant technology domains, the aspect of life affected, and search for relevant articles based on keywords. BLIP will return articles using a semantic search based on the articles, titles, and summaries, and users are also able to shuffle the cards for new inspirations. If the users are interested, they can also import an article, for example here. And it will show a brief summary of this article after running the BLIP content curation pipeline. Specifically, this article talks about disinformation in Kenya's 2022 presidential election. If users are interested, they can open the article to read further. And finally, users can bookmark the article that they are interested in. Now let's talk about evaluation. In our first study, we asked 3 main research questions. First, does BLIP support CS researchers in discovering undesirable consequences beyond their prior knowledge and searching on the internet? Second, how do researchers perceive BLIP's usefulness for discovering undesirable consequences in their area? Third, and how and when do researchers imagine using BLIP during research? To answer these questions, we recruited 9 researchers, 3 working on research topics in social media, 3 on voice assistants, and 3 on virtual reality. Each participant has authored at least 1 peer-reviewed publication in one of these technology domains. In Condition 1, participants were asked to think about and list any undesirable consequence in their domain of expertise. In Condition 2, participants were asked to search any online resources of their preference, for example, Google Search, Google Scholar, Semantic Scholar. The goal is to add to the previously generated list. In the last condition, we asked participants to interact with BLIP and list any additional consequences that they didn't mention in either of the prior conditions. Here's how we analyzed the data. To answer question 1, we analyzed the number of unique ideas listed during each condition and the diversity of the aspect categories of each idea. To answer question 2 and 3, we conducted a thematic analysis of the semi-structured interviews. Several insights. BLIP allows participants to find additional and diverse undesirable consequences. Participants listed an average of 6 unique ideas in condition 1, followed by 3 additional ideas, and added an average of 7 ideas in the final condition. They also generated around 4 aspects in the first condition, 3 in the second, and 5 in the last BLIP condition. BLIP is also useful for learning about undesirable consequences and reflecting on their own experience. For example, P6 mentioned, I do feel like it's very nice to get exposed to a wide variety of topics. I feel like this would be great to anticipate undesirable consequences of a new social media product. BLIP can be useful for brainstorming undesirable consequences, writing ethics statements, and for different stakeholders. For example, P9 mentioned, I think in order to get a sense of the full paradigm of VR, you have to have a tool like this, because you can't just read a bunch of disconnected articles about this. Our first study showed that BLIP can be helpful for a selection of only 3 CS subfields. We then follow up with a second study to answer question 4, to what extent is BLIP useful and actionable for users' own projects? To do this, we recruited 6 researchers working in very different CS research directions. Then, BLIP automatically generates content for the participants in their fields. During the study, participants were explicitly instructed to use BLIP to bookmark as many consequences as they may find relevant to their own projects. We had participants explore BLIP for a maximum of 30 minutes. In the end, we tracked the number of bookmarks, conducted thematic analysis on a semi-structured interview, and a post-study survey. Overall, participants found and bookmarked summaries that were relevant to their projects. Participants also generally perceived BLIP as useful and actionable. Some participants thought they would integrate BLIP in their work in the future, but other participants thought the task of addressing undesirable consequences as tangential to their primary focus on the technical development. For example, P6 mentioned, "I learned a lot about social impact by looking at BLIP, but P6 research primarily focuses on building a technical system." In other words, they didn't think that they were at the right position or qualified to think about and address these issues. This indicates that even though BLIP is a useful tool, it's not a magic bullet to achieve this paradigm shift alone. Doing so would not only require a catalog of the concrete consequences by BLIP, but also a systematic change in culture and structural incentives. Now we want to talk about the limitation of future work. First, we would like to include more and more diverse content source, more than the technology, magazines, and Kai papers in the current version. Second, we would like to engage diverse user groups to share their own experiences, in addition to the online articles and papers. Third, we'd like to understand and mitigate potential LLM bias. Large language models can introduce serious undesirable consequences as well, such as hallucination, biases, and limited understanding of emergent fields. We partly address this by extracting information directly from trusted sources and offering access to the original content, instead of directly prompting LLM. But nevertheless, future work should involve users to improve the overall quality of this process. Lastly, we are also excited and envisioning many other potential interesting applications for not only researchers but also policymakers, journalists, or general public to gain awareness of undesirable consequences in various CS domains. With that, thank you so much for your attention.